This is the Math 107 Lesson 11 demonstration portion of the lesson. Okay, first, identifying the domain and range from a function's graph. The graph of the function y equals f of x is given below. Recall that the domain is the set of all inputs and the range is the set of all outputs. So your domain is the set of all x values that your graph lives on. So this would be your domain. And your range is the set of all y values that your graph lives on, the smallest to the biggest y, and the domain is the smallest to the biggest x. You might have to take some out if the graph doesn't live there, but it's generally smallest to biggest. So here is a function drawn, and we want to identify its domain and range. So domain is the set of all x values where the function lives, listed smallest to biggest. Okay, so let's see, the smallest x value is here at -7. And then it looks like the graph continues to the right and up forever. So my domain is -7 to infinity. We never include the infinity, so you put an open bracket there. And then the -7, because this is a closed dot, -7 is part of the graph, so I put a square bracket there. If this had been drawn with an open circle on the -7, like that, then we would put a an open parenthesis, because the -7 is not actually part of the graph. But in this case, it is. Okay, so the range of my function, that's the set of all y values where the function lives, and that we can calculate by looking for the smallest or the lowest point on the graph up to the highest point on the graph. So my lowest point looks like to be about right here, and that's at a y value of -2. And then this continues up forever because the right part of my graph is going to keep going up forever. So my lowest point is -2, my highest point is infinity. Include the -2 because that's a closed circle here on that point. Okay, even and odd functions. An even function is symmetric about the y-axis, which means that when you have a positive x and a negative x, you get the same y value. Okay, so for an x value of 2.5 versus an x value of -2.5, here and here, you get the same y value, -14.44. An odd function is symmetric about the origin, and that means that if you plug in a positive x and a negative x, you get opposite y values. They'll be the same number, but one's positive and one's negative. So for this example that we graphed here, we have +1.28 and -1.28, and they give the same number for y, but one's positive and one's negative. We call that origin symmetry. And functions that have origin symmetry we call odd. So this is just a little summary of that. And that's it for the demo portion. You should work on the class activities and then watch the video for them after you have completed them and checked your answers.